Hey everybody, it's Jeffrey here. Hope you're having a good day. About 2 weeks ago I decided to do a video where I was going to prove that the moon was not hollow. And by not hollow, I mean not hollow like these pictures up here or this structure here, because it seemed like that would be pretty easy to prove just by doing the calculations using the orbit and speed and stuff like that. So I thought that I could prove it mathematically pretty easily until I started getting into the math. And here we have Kepler's third law, and we can look at this. This is a nice little overview of what you run into when you're trying to do all this using Kepler's laws, Newton. I'll just scroll through this because it's actually a nice little lesson. But basically what I'm doing is I'm trying to give you an idea of the real basics here involved. So here's the gravitational constant for Earth, how they come up with that. Now, it's very interesting. They want to you want to find out what the mass of the sun is. But you have to look at the orbit of another object that goes around the sun. So Kepler's third law really only works for things like the Earth around the sun, the moon around the Earth, Charon around Pluto. So you have to have, you want to find the mass of the object that's being orbited. Like the Earth, you would use the sun. In this case, they're finding the mass of the sun using the Earth, because an Earth is a satellite of the sun. Here are the equations. You can work through it. Then we have to modify the laws. And here we have the mass of the sun finally. Pretty easy. What about the Earth? No problem. Just use the orbit of the moon. But what about the moon? This doesn't really work unless you can find a satellite that's going around the moon. Well, it turns out that you can. But I was troubled with the fact that how did they get the first vehicles to orbit the moon if they hadn't already been there? So to explain that, you really have to know the history a little bit. And here's the perfect article if you want to just know the history of how they measured the moon's mass. And this goes on pretty far back. The Greeks over 2,200 years ago established reasonably accurate values. But the mass of the moon was unknown and the density could not be calculated. So even the moon looked like a sphere of rock. This could not be scientifically confirmed, although the first scientific steps towards ascertaining the origin of the moon could not be taken. And they go through a lot of the early measurements, how they did it. The ratios worked pretty good. So that was another way. Another way was using the tidal approach. And you can read that. I'll try to stop it enough that you can stop your browser and go through there and read that, but it's a pretty interesting history, and they slowly but surely are getting closer and closer. And then they move on to precession and nutation. There's all these different methods that they can use to estimate what the mass of the moon and the density is. And we're almost to the end here. Parallactic inequality. So they're using all kinds of methods here to finally get to some realistic equations. I'm just scrolling this because this is actually a pretty good description on the history of how they calculate the mass of the moon. So this down here, then we have the conclusions here. Should probably read that. And really the point is here is, even after all of that, they still didn't really know how to do it. But they had some pretty good estimations. And what troubled me was, how did they get the first vehicle to the moon if they didn't know all this stuff? Because you kind of need to know it. Well, I think they used everything they could, and it worked out. Now here's another nice article here. Them goes through here, and here they're going to find out all of this, the density of the moon. And this is something that anybody can do, apparently, to experimentally determine the radius, acceleration of gravity of mass due to the density of the moon using simple methods. And what they did, first of all, they got the diameter of the moon using this equation right here, put in the values that they got, and came up with a chart. And then for the varying distance from the center of the mass of the object being orbited, they have these distances. And then they have a program that they use to determine the acceleration of gravity on the moon by how high these guys were jumping. And as we know, they were jumping a lot and falling down and tearing up those $10 million spacesuits. And after all that, we've got charts. They finally get this. Here's the gravity of the moon, which is very important because you really need to know that. Then we use that to find out the moon's mass, and that mass number is pretty accurate. It's right about what it should be. Estimation of the moon's density. Now they're using that to find the density. And here's their results. Everything's pretty close. The mass of the moon, 7.4 times 10 to the 22 kilograms. That's right. And then the average density of the moon, 3.4 times 10 to the 3rd kilograms per meter cubed. And we have the acceleration of gravity. So those are all right. So basically what we know now is that we need a satellite going around the moon before we can find out what the mass of the moon is, or at least that'll help. And so here we have a free NASA lesson here, and we have the service module, the orbit period 2 hours, distance of 1737. Now the way this works is we have the planets. The farther away you are from the sun, let's say, the slower the planet travels. And the closer, of course, the faster. Now, Jupiter could be sitting here in place of Mercury, and Mercury could be out here, and they'd still be going the same speed. So Jupiter would be going the speed of Mercury is in here. It'd be going really fast. Because the way it works out is when a satellite is orbiting a planet, it doesn't matter how heavy it is. It's the speed and the distance from the planet is the only thing that matters. And the reason is you'd think, well, the heavier it is, then, maybe that would have some effect, but it doesn't, because it's the same as the feather and the hammer being dropped in a vacuum. The gravitational pull is the same on both, and if there's no air to slow it down, they go at the same speed. So you could have a feather going around the Earth. If it's in the same orbit as the moon, then it has to go the same speed as the moon for it to stay there. If it goes any slower, it'll fall. Any faster, it'll fly away. So back to the math. There are easy ways to find this. I'll just go ahead and blow this through here. And you can stop at any time, read the problems here. There is the answers. This is the mass of the moon. Now what's the density? That's easy too. In fact, it's really easy. A lot more easier than you think. Really just taking the volume of a sphere, we know the mass. Now we know the density, 3.4. So no matter how you do this, you still keep coming up with those same numbers. Here's the mass of the moon. We just saw the density. These numbers are all the same. You can use all these different methods that these people use, but this is their final numbers that they come up with on the far right hand side there. So those are right. They have to be. They're not exact. I would say the most accurate was the 7.4 down here, because all of these digits they have way out here, 1, 2, 3, 6 digits out and stuff. Some of these numbers are not realistic. You can't really carry it out to that many digits. Because of the percent of error carries through on this stuff. So in the end, when the mathematical dust clears, what we have is the moon density is 3.4 grams per cubic centimeter. Earth is 5.5 grams per cubic centimeter. So there's a big difference right there. And a couple things I'd like to say about the moon before we move on to that you might want to keep in mind. Something that I've never always wondered about is, as we know, the moon always faces the Earth. Now the backside of the moon isn't dark all the time. It's lit up when it's facing the sun. It circles the Earth as it goes around the sun, so the moon gets light. The backside of the moon is actually heavier than the front of the moon because there's a bulge back there. And you would think, oh, well, it's a centrifugal force. No, it's not the centrifugal force, because the gravity works evenly on the moon. It just pulls the whole moon. It doesn't just grab the back and pull it around the heaviest part. So the moon was placed, or somehow got that, into orbit so that it faces us all the time. This bulge part is on the other side. And the second thing is, why are all these big huge craters on the side that the Earth is on. So they all had to come from an angle, or just graze Earth to hit the moon fairly straight. Otherwise, these asteroids or whatever had to have gone through Earth to hit the moon directly. So there's a few other things too. Like on the moon, you think, well, okay, if this is a satellite, where do they get all the dirt? How did they pile that on there? Why are there so many craters on the moon? Especially up here on the top. It's really rough. And the back is pretty, I would have to say mountainous. So that's an awful lot of material to cover your satellite with. But something's going on here, because the density is only 3.3, 3.4. And then there's a problem with the density too, because seismic tests have shown that the center of the moon is not as dense as the outside part of the moon. So what has the math shown us? Well, the math has only shown us that the density is 3.5 or 3.4 grams per cubic centimeter. Well, we know that that's a lot lighter than the Earth. So what's going on here? So here I am over at Strange Moon Facts, and here these are the problems that are pretty legitimate here. Like, for instance, the moon's age. This is very incriminating, and you can read this too, I guess. I hope you can read this. YouTube's been posting videos in low resolution when they're uploaded in HD, so I wonder what's going on there. So hopefully you can read this. But basically got the moon's age. The moon is older than the Earth. Okay, you can read it there. Oldest age for Earth is 4.6 billion years. Moon rocks are dated to 5.3 billion years. And the rock's origin, the chemical composition of the dust which the rocks sat, differed remarkably from the rocks themselves, contrary to accepted theories that the dust resulted from weathering and breakup of the rocks themselves. The rocks had to have come from somewhere else. So if they just picked up a moon rock and brought it back, there's no guarantee that that really is the moon. That could be anything. It could be from anywhere. They need to drill, do core samples if they want to know what's in the moon. They haven't done that. We got some heavier elements on the surface. Water vapor's been found. The rocks are magnetic. There are no volcanoes. Moon mascons. These are some kind of disks that are underneath. It's like 20 to 40 miles beneath the centers of the moon's maria. We have seismic activity. Hundreds of moonquakes are recorded every year. They don't know what's going on. It's not getting hit by anything. And there's been reddish glows too. Now we have the hollow moon. Now they're saying here, over here, that it's like hollow. It's more hollow than it is homogeneous sphere. Well, the moon doesn't necessarily have to have a hollow center, which I think is impossible. It could be that, I don't know why the middle of it is less dense than the outside, or the density is lower, and you would think it would be the opposite. There's a huge problem right there. We got moon echoes. We got unusual metals. A lot of titanium laying around up there. Brass. Other things that shouldn't be there. Uranium-236. Neptunium-237. Can't even find that stuff on Earth. Moon's origin. We'll go over some of these theories here where they think the moon came from. It's all BS, though. The orbit is very important. And this is interesting. The moon's center of mass is 6,000 feet closer to the Earth than its geometric center, even though the bulge is on the other side. The moon is just in too precise an orbit to have just, gotten there by itself. The diameter is just the right distance. Spaceship moon. And we have the flashes. Operation Moonblink, and that's where they detected about 28 lunar events in a relatively short period of time, and they were seeing all kinds of these flashes and colors, and then we have the shapes on the moon too, and we got the shard, the tower, the obelisks, not to mention all of the what looks like apparent openings on the moon's surface to go in the moon. And I've even seen videos where it looks like things are going in and out of the moon. So something's in the moon. So as far as the density is concerned, is there any reason to believe why the moon does not have hundreds of tunnels? Underground bases, whatever. That could change the density, because I don't think anybody actually has really checked the density other than from the mathematical calculations. And then here we go, 7 irregularities that suggest Earth's moon was engineered. And I'll just kind of scroll down here a little bit. Basically goes over a few of the things we just talked about. Here's one of those openings right there on the moon. Here's the structured moon. It seems engineered. And like we just said, it's got elements it shouldn't have. It does not have a solid core like every planetary object. And I'm not sure what researchers are 100% sure, in fact, that it is hollow. I think it is a very low intensity interior, but I don't know about hollow. That's an awful lot of material that wants to go to the center. And, I don't know, getting hit by those huge asteroids, what it looks like it's been hit by huge asteroids, that's got to have some effect. The moon is older than the Earth. We already talked about that. And it's got this strange orbit. Titanium, precise positioning. This all matters. So really what this all revolves around is that density, that low density, that just really shouldn't be. So here we are at Humans Are Free with their article on this. And I'll scroll down here a little bit, you can read about that. What I really want to get to is the theories of why they think the moon is there. They, I'm not sure who they are. Capture. This one goes on about how the moon was just captured by the gravitational pull of the Earth, so it was just moving. I don't know why, how it got all the way to Earth, and it just stopped at Earth and just went right into this perfect orbit, facing Earth, never spinning, but, rotating, and just perfectly too, almost, 27 days to make a complete rotation around the Earth. Everything's so timed. Then we have fission, oh, this was forming while it was still molting, spinning to the planet, just threw this material out there and it just formed the moon. So then wouldn't it be the same density? Pacific Ocean, debunked in maturity, the ocean floor, which is true. Accretion, the hypothesis of the Earth and the Moon formed together as a double system. Well, they came from the same material, and then why are they so different? Reactor explosion, more radical alternative. In 2010, proposes the moon may have been formed from the explosion of a georeactor located along the core mantle boundary of the equatorial plane of the rapidly rotating Earth. Okay, giant impact theory. This is the one I hate the most. Commonly accepted to. A body the size of Mars crashed into Earth, expelling a large piece of mass into space, which has rounded itself out and became miraculously a different density and a completely weird moon with the makeup of the core being lighter and everything. So that doesn't work. So there's all this disagreement on how the titanium got there and what it's doing here in the first place. So they're still trying to attach it to Earth somehow. We're right back here to the Earth's age again, compared to the moon. The moon being older, we got origin of the rocks, heavier elements. I think we just went through all of this. So, do I think the moon is hollow? To tell you the truth, I don't think anybody knows. I don't know. It's hard to say it's a contraption like they have in some of those pictures that we saw, because we don't really know that. We don't know if there's anything mechanical inside that moon. All we know is what we see from the surface. We've landed there a couple of times, but one thing's for sure, the density is small, so it really doesn't belong there. How it got there, I don't know, but considering that life in this galaxy or universe has been around for billions of years, it's not that unbelievable that this was brought here from somewhere else. And there's no reason to think that if a civilization had possession of this moon, how much work can they do on the interior of this, what might have been a planet to start with, to completely transform it into a like a satellite ship. And if you worked at it for hundreds of thousands of years, building one tunnel after another, and keeping the moon on the outside looking like a moon, it just doesn't seem impossible anymore. It's hard to imagine that anybody could move the moon from anywhere and then bring it here. But who knows? Who knows what can happen out there? But my bottom line on this is I have to go with, I don't think the moon is from Earth. It had to have come from somewhere else. The mathematics don't prove anything either way. As like I said, the only way to know is to go to the moon, drill the holes, but then we have some problems. The Apollo mission stopped suddenly, no explanation. They probably discovered something that was just too big just too big, and who knows, they may have been warned off. So look, don't dig in any holes in the moon and finding out anything here. We'll let you go up there and play around a little bit, but that's about it, because it seems very highly likely that the moon would be the place to start off with a good big moon base before you go taking off for Mars. So there's just too many things that just don't add up here. So that does it for the hollow moon as far as I'm concerned. At this point, I still don't know, and I don't think I ever will know. And that's about all I can tell you. I could not prove the moon was not hollow. In fact, if anything, I almost proved it was hollow. So, with that, have a good day.